Good afternoon. Again, welcome to the EMS Virtual Summit. I think in these strange times, everybody would love to be in Berlin now, but all of us is locked up at home, or at least most of us. If any of you would like to ask a question, please raise your hands. Just joking. Feel free to ask them after the presentation, and I'll be more than happy to elaborate on them. So, what is on the agenda today? I would like to talk to you a little bit about the customer requirements that are process and market driven, the customer headaches, what kind of a solution we can offer, the valuation of these advantages, the carefree service, then a small summary, how all of this relates to Industry 4.0, what is quite important these days, and the impact on the compressed air ecosystem. So for the customer requirements, they have very high expectations. In most of the segments and most of the companies, we are actually located in the utilities. So not as a process itself, but as a utility. But anyhow, the air quality needs to be 100% oil-free air. The total cost of ownership is what we are measured on to actually switch or stay with the current supplier or do whatever. Reliability, availability is of course one of the most important things. Flexibility is key. It means that the supply needs to match the demand. New industry shifts are here, also in compressed air. That is a little bit slower industry, which is for Industry 4.0, and actually assets-free operations. Of course, in practice, things can be quite different. No monitoring, maintenance is only done when it's too late, limited knowledge on specific technologies, and no visibility of the key parameters that have actually failures as a consequence. Nobody wants that. So installations can also be quite big. A lot of air is needed in larger plants, so there is a high dependency, and it's also quite difficult sometimes to match the supply onto the demand. The integration in the SCADA systems can be very challenging. All the electronics, closed software, limited available data. However, at Tamturbo, we try to do things differently. We try as much as possible to accommodate these specific customer needs. And our slogan is touch-free, carefree, and we try to live up to the customer expectations and go beyond. On this photo, you can clearly see the quality of our machines. It's all stainless steel piping, stainless steel cable trays, and much more. So to develop long-lasting quality is to be carefree in some way. In a lot of cases, the total cost of ownership in compressed air domain, oil-free domain is actually mispresented as three parameters: maintenance, service cost, and investment cost, and energy. However, in practice, a lot of other parameters are also influencing the total cost of ownership, like the time needed for planning, guided interventions on site, corrections of settings. A lot of time and money is actually wasted. So I would like to present the total cost of ownership in a more elaborate way. So you will have the atmospheric air, the compressed air. This is the process, of course. You will have the electrical energy. You will also have the reusable heat, which is often forgotten. Of course, you have the investment and the service cost, but you also have some issues like the quality of the compressed air, the efficient flow control, but also other ones like the noise, the footprint. So did you know actually that 10% of the global industrial electricity consumption is being used by compressed air? It means 5% of the world electricity consumption is going to compressed air. This is growing 5 to 7% compounded annually. If your car would have the same life cycle cost as a compressor, then 3.5 times the purchase cost would be the lifetime cost and ever increasing fuel consumption. So if it's new, it would be 5.6. 4-year-olds, it would be 7.6. Yearly maintenance would be around 5K. Every 5 years, you would need to have your engine rebuilt. I think it's quite clear that this would not be sustainable. And this is an example with traditional technologies. Now, During the last years, I think the focus on climate change has been enormous, with a clear reason. There has been several forecast models. This is one of them. This would be a representation of the world when the average temperature would be 4 degrees warmer. The whole yellow part would become inhabitable. So I think it's quite amazing to see what the impact will be. Now, of course, climate change can start with compressed air because 10% is being used of the industrial electricity consumption. A lot of people are changing light bulbs at home, but clearly there is a much better way and a much more influencing way to do this with compressed air. So the market value in 2016 was around 13 billion, of which 20 to 25% is oil-free air. Now, also the cost of oil-free air is quite big because 85% is heat, which can be reused, but only 15% is air. And of that 15%, 50% is only going to the production. 50% is wasted as well in the form of leaks, artificial demand, and inappropriate use. So the challenge today is actually the inefficient technology. So there are several oil-free technologies. You have the oil-free screw, you have the traditional geared turbo compressor, and you have then our technology. The major difference is in the use of components. We don't have any gears, oil seals, or mechanical bearings. None of them. A traditional turbo is already quite a good technology, but still there are a lot of components that are not needed. And of course, an oil-free screw, yeah, it's actually designed for maintenance. So that's a much more difficult technology to call efficient. Of course, there are many technology improvements. In this graph, you can see an overview based on a study that has been done to sketch the different technologies based on their maximum attainable efficiency. And then you can clearly see that here you have the centrifugal technology. Here is the oil-free screw. It's much lower. It's the purple line that you will see. So in these technology improvement, it's a high-speed, direct-driven VSD Tamturbo machine. So here you can see the base module of our technology. It consists out of a permanent magnet motor, 2 impellers on the shaft, one here, one here. This is a 2-stage module. The magnetic bearings that actually levitate the shaft completely. The air will be coming in here, coming out here. The high-speed motors, of course, have permanent magnet, are synchronous motors. They have a very high efficiency, and they're variable speed driven. What actually means that we can react very quickly on any flow or pressure changes. And the maximum RPM of these motors is 35,000 RPM. The active magnetic bearings, they allow for a very good balance because they will have a 14 kilohertz position measurement and steering. So the PID circuit will be constantly adjusting the position of the shaft. So there is no wear, there is no friction. Added to that, here you can see actually the flow chart of our compressor with the blue and the red piping. It's the water circuit that you see here. The complete machine is water cooled. So you will have the air coming in the machine here, going out here. We have 3 stages, and ultimately coming out here as cool compressed air. But of course, there is still a lot of heat in the water circuit. All this heat can be recovered. We have 3 different ways of recovering the heat, where we can have starting from 65 degrees water out until above 90 to have the maximum flexibility on reusing the water. We would really like to stimulate reusing the hot water because, as we said, it's 85% of the energy of the machine. So companies that start to use the hot water from the compressed air circuit will gain actually a lot of money. It's a carefree technology. Why is it carefree? Because it's free from rising electrical bills. We have a stable electricity consumption. It's free from maintenance, free from environmental loading. We don't have spare parts that needs to be changed every 1,000 hours. There is no surprises because we do remote monitoring. So how does it look? Here on the left side, you will see a typical, we will not go in detail, but you will see a typical maintenance schedule for traditional oil-free air technology. You can clearly see the length, you can see the kind of visits. There is a 4,000-hour visit, an 8,000-hour visit, a 12,000-hour visit. So, you know, it's a very extensive maintenance schedule, whereas at Tamturbo, you have a carefree contract. We cover all the consumables, the wearing parts, the spare part, the needed labor to keep the units running. It also includes the remote monitoring and optimization of the control algorithm that will be specifically adjusting to your production needs, including a warning system where the production people can be included in the alert. So it's a carefree contract. Now, how do we get to this lowest total cost of ownership? Our aim is to transform the market towards a more sustainable alternative. Our aim is to transform the market from using polluting oil lubricated machines towards oil-free. Now, how will we do this? So, as you see, the energy efficiency here at the right bottom corner is a stable energy efficiency. The centrifugal technology is not a technology that deteriorates. Because it doesn't deteriorate, there is no need of doing this overhaul of the elements every 5 to 10 years. Because of this, in the life cycle, you reduce a lot of costs as well. Also, this is only comparing the technology itself, but if you use an oil lubricated machine, which is of course a little bit less expensive, it uses a lot more money on maintenance, but also you need to filter the air continuously and replace these filters. So ultimately, comparing the technologies, the technology is more efficient, you pay less for the maintenance, and in your compressed air system, you also have a lot of benefits. So what does it mean in money? In money, it means that if you compare the difference in capital investment between installation one Tamturbo and another one, it means that you will have a payback of less than 1 year. Industry 4.0 is a key aspect of the future. What we do different than the traditional industry is that we measure everything that we can, and we display it as well openly for our customers to follow at the machine or remotely. Because we use a standard PLC as operating platform, SCADA integration actually is quite easy. Now our asset, your asset, is connected to our centralized Tamturbo technical support team, who are constantly monitoring the machine and warning you if something is bound to go wrong. Here you can see 4 different print screens of the actual interface that we use in our technology. This remote monitoring is different than using an on-site technician. It's a 24/7, 365 days a year solution. There are notifications. You can have a coordination with local maintenance personnel. You can have remote fixes, remote restart if required, where you have only somebody on the phone guiding the process. There can be a periodic review of data logs, operational data. The performance can be optimized using changing conditions. So there are a lot of different possibilities. But of course, as I already mentioned, the machine is only part of the installation. And to transform from oil-injected air to oil-free air, it's a huge advantage. You need less components. As you see here, this is a typical oil-injected installation that you see. You have the compressor, sometimes an added aftercooler to reduce the inlet temperature for the dryer. You have a lot of filters, 1, 2, 3, 4. You have sometimes an adsorption dryer. And then starting from here, you will have the nitrogen oxygen generation if required. But because you have oil injected air, you also need a water oil separator because the condensate is contaminated with oil. So there is a lot of waste. Added to that, because you have all these components in the system, there's a huge pressure drop. every component has a pressure drop. So the more components you have, the bigger the pressure drop. Every 1 bar of pressure has an 8% power effect. So if you go from 7 bar supply to 6 bar supply, you immediately reduce 8% of the power. Now, the compressed air ecosystem, to sketch a little bit the advantages. As said, with Tamturbo, the whole system is monitored. So we not only monitor the machine, we can monitor the dryers, the filter. Actually, we can include everything that is needed of the installation to put it online. Now, if we start at the beginning, let's say we always compare against oil lubricated because we want to change the market towards oil-free. As I said, the investment maybe is a little bit lower, but the maintenance is very high and the air quality is, of course, contaminated. So there is a huge environmental load. If we go more to the traditional technologies, the investment is high, service is high, and there is an overhaul needed. So also there, the total cost of ownership is very big. Only actually today at Tamturbo, we have a disruptive business model that actually allows for the total cost of ownership. We don't have any air quality risks, and we don't have any big environmental load because of using contaminated parts that need to be changed. On this disruptive business model, there are a few notes. So we can either use investment and maintenance like a traditional compressed air business model, because it's used everywhere today. We can do an investment and then the carefree service package where it will last up to 10 years. All wearing parts, spare parts, labor remote monitoring is included. But we want to even go further in this journey to transform the market. And what we offer there is touch-free air, meaning that all the expenses related to the compressor are actually included in a cost either per cubic meter or per month. We do this to avoid the capex cycles in a lot of companies that actually sometimes don't allow to change easily towards new technologies. And this is a way that really allows you to test and to experiment with this very disruptive and good technology. We're only a young company, so we're ambitious with our innovative technology. We have started about 10 years ago, where the company was founded. The first years, we have done the R&D phase, everything that was needed to actually get a product. And then starting from about, let's say, 2017, we were really starting to sell. And since then, we are only grew exponentially. Now we have actually almost a machine on every continent. Those machines starting to talk for themselves. They start to get in the market, attracting new customers because the customers are so enthusiastic about what they experience with our technology. So it's a huge journey that we are going through. Some of our reference customers, they're so enthusiastic that they even do the selling for us in a sort of way. So what better reward can you have than customers that are so happy? Why? Again, a small summary before we talk about the reference cases. There is absolutely no oil in the compressor. So we satisfy the quality requirements. We eliminate all the risks of the contaminated air. We don't need the oil water separator. We take away the risk as well for the capex cycle. We take away the risk for the maintenance by offering a carefree, all-inclusive maintenance program, which is unseen, especially at the cost that we can offer this because of the technology using the magnetic bearings. One of the world's leading brewing companies has chosen our technology in their compressor replacement plan. So they have clear sustainability targets. They use our TT185. It's a machine of about 200 kilowatts, totally remote monitored. And now it's running successful. He's even changing the next machines and other plants. In Belgium, there is a major potato processing plant that is making all varieties of products from French fries to hydrated flakes, granulates. And this company has a specific focus. They want to have a circular economy completely at themselves. So they have a power plant where they use actually the waste product of the potato processing production to generate electricity. This electricity again is then used in the plant, but also for all the utilities. So it's a complete and circular economy in this production facility. They do about 2,500 tons of potato daily, and this will turn into 300,000 tons of finished products a year. It's huge. And their greenfield plant, we were chosen again to help them, and they also are looking at the second machine. These are only two references that I've chosen to showcase, to highlight, to show you what we can do. This was my presentation. Thank you very much for your attention.